And with that, I'm going to turn things over to Mr. Arjun Narang, Technical Marketing Engineer from Maxta. Arjun, it's yours.
Thank you, Scott. Thanks for the introduction. And hello, everybody. As Scott said, good morning to some of you, good evening to others, good afternoon. My name is Arjun Narang. I am a Technical Marketing Engineer at Maxta. And today I'm going to just discuss with you kind of Maxta, hyper-convergence, Maxta's approach to hyper-convergence, and where we really feel the market is going and how we fit into that market. So as a company, Maxta is built on 4 core principles, and that's kind of what will be the focus of today's presentation. And those principles are to be a flexible, simple, scalable, and cost-effective platform for your hyper-converged storage needs. As a company, we're funded by Tier 1 VCs. One to talk about here is Intel Capital, because not only have they provided us with funding, monetary funding, but they are also a development partner, which I'll discuss in a later slide, but that relationship is, very key and very beneficial for us within this market. And when we go to market, Maxta has 2 solutions. We are a software-centric company, so the primary solution that we have is what we call MXSP, or the Maxta Storage Platform. That is a software-only solution, which you can use, you can leverage your existing hardware, or you can acquire new hardware and load the software on that. And for customers who kind of prefer pre-built reference architecture type of solutions validated, we have the Max Deploy Hyper-converged appliances. So both are built on the same software, just 2 different ways to consume that software. And so to get started, I kind of want to take you guys through where hyperconvergence is coming from, what the storage market used to look like, what many of you may have with traditional storage arrays in your environment today, why hyperconvergence came in, and where Maxta fits within that hyperconverged landscape. So if you look at the modern virtualized data center, what you really care about as an administrator are your VMs and the applications that are running. So your Exchange applications, your SQL database, your web server, your file server, all running on those virtual machines. But in order to support that environment, you need your hypervisors, you need servers, you need networking gear, you need storage arrays, all with their interconnects and all different components from different vendors. And so the issues here, there are a few issues here, and the first one is cost, right? You have these multiple products from multiple different vendors wherein you have to maintain multiple support contracts. You may be getting your servers from vendor A, your switches from vendor B, and your storage array from network C. And you have multiple support contracts, and you have to refresh all of these different products on different cycles, and everything gets thrown in and out of the environment every 3 to 5 years. And the complexity associated with this also, right? You have different vendors, different components to the whole data center. So you're going to have a networking administrator, a storage administrator, a server administrator, a virtualization administrator, and you're going to have different management consoles for all of these admins, and you need an expert in each of these areas in order to manage just those VMs that you care about. In terms of flexibility, there's been a lack of innovation from a storage perspective in storage technology over the last decade. And even when there have been those innovations, it's very difficult to take advantage of that because, again, as we mentioned, you have to rip and replace that entire storage array that you invested in. And when it comes to scaling and maintaining performance, right, this is a very difficult equation in the traditional storage market. Really, if you want to scale your performance, you have to bring in another storage array. And when you bring in another array, now you have another element in your data center that needs to be managed, troubleshoot, maintaining a separate support contract, and everything that we've discussed in terms of the cost, complexity, and lack of flexibility. So now if we look at where hyperconvergence has come in and really the transformation that we're trying to bring about within the data center is this idea that, okay, we're going to take those 3 separate components, we're going to maintain your VMs and the things you care about, but we're going to collapse the infrastructure into just your standard commodity x86 servers, loaded with some spinning disk and some SSD capacity. With that, you're going to see the benefits, right? You have this simplified infrastructure. You've gone from those 3 different components now to just one single, x86 server in a clustered environment. You have this ability to scale. You can scale up, you can scale out, and we'll discuss that a little further, within Maxta's software-defined approach, how you can take advantage of the full scalability. And of course, these environments, these hyper-converged solutions, you'll find that most of them are built for the virtual environment. And what that means is that you're going to get this single user interface that's integrated into the virtualization layer. And so that's going to provide much more simplified management with everything done at a VM level. So if we look today at the hyperconverged competitive landscape, at Maxta we kind of see 4 different boxes essentially that all of these companies and vendors in the hyperconverged market fit in today. And you'll probably hear more about that throughout the day today as you listen to other presentations. What we really see are, there are vendors who give you flexibility, and there are vendors who are going to give you less flexibility. And that flexibility comes both in your choice of hardware, which would be, your server vendors, for example, and the hypervisor. So whether you're able to run, just VMware or, VMware and KVM and other hypervisors also. So if you look at kind of the first approach to the market that we'll discuss is the hyperconverged appliance. So the hyperconverged appliance is going to lock you into a single hardware vendor, while it may give you the choice in hypervisor. So you could be running VMware, you could be running KVM, you could be running another hypervisor, but you're locked into maybe Dell or maybe Cisco as your server vendor. And it's going to make it very difficult to scale and rip and replace. You're going to have to rip and replace your environment as you grow and as you refresh. Now, on the other side of the spectrum, we have the software-only solutions. And many of these you'll see are going to give you your choice of hypervisor. So you have the ability to run on VMware, run on KVM, run on Hyper-V. But they may give you also, flip that around. So they're going to give you the choice of hardware where you can run on any server of your choice, but some of them will lock you into the hypervisor. So you may only be able to run on VMware, or you may only be able to run on KVM. And so you're going to see kind of, as we've seen throughout the years in the data center, this transformation, right? Today, VMware is great, but maybe tomorrow you want KVM, or tomorrow you want, Zen Server or something else. So you don't want that lock-in. And then, of course, there are some solutions which are going to tie you into both the server vendor and the hypervisor. And what Maxta really sees as the strategic vision within this market is the complete flexibility, having your choice of hardware and hypervisor, allowing you to leverage your existing hardware, providing you with the scalability options that you need to meet the exact needs of your data center. Basically, you get your choice of hardware, your choice of hypervisor running with the Maxta software to give you the enterprise storage capabilities that you need. So here are just a few kind of quick points on the partnership that Maxta has within this software-centric approach that we have. So the key here is that, in order to maintain that flexibility to run on any server and to support any hypervisor, we have to have strong partnerships with some of the key players. And the key players in this market, when you're going with that hardware flexibility for hyperconvergence, are going to be, the key components within the server, which are provided by Intel, and the key components for storage, which are provided by LSI, which is part of the Broadcom company here. And LSI is the primary manufacturer of RAID controllers and the HBA cards. So Maxta's strong relationships with both Intel and Broadcom have allowed us to support the Xeon V4 processor along with NVMe and other SSD technology from day zero. And additionally, with the Broadcom relationship, we're able to support the next generation HBA from day zero. And of course, from the hypervisor's perspective, we've supported all new releases of VMware vSphere from day zero also. So now looking at kind of 3 key differentiators that Maxta has within the hyperconverged landscape, you can see here we have the ability to maximize your choice, software agility, and the application-defined platform. So starting with maximized choice, as we've discussed, these vendors that are going to tie you into hardware give you that restricted list of hardware options. But Maxta, being a software-only solution, lets you choose your server vendor and even mix and match within your environment and leverage your existing hardware. Similarly, being a software-only solution, we have more flexibility when it comes to a transferable software license. So most vendors will force you to repurchase their software in addition to the hardware when you hit a refresh cycle. But Maxta has a transferable software license, so you can carry over that license to new hardware at no cost when you upgrade. And then from a technology perspective, Maxta is an application-defined storage platform. And what we mean by that is that most vendors are going to give you a storage platform that treats all applications the same. Maxta, on the other hand, allows you to optimize your storage on a per VM basis for each of your applications. And I won't spend too much time on this because we're going to discuss it further throughout the slides today and during the demo. And finally, of course, you can't have all of these without having the enterprise class resiliency, availability, and performance that you expect from an enterprise class storage solution. And so just a quick discussion here on Maxta's architecture. We are a minimum 3-node environment, so 3 x86 servers to form that cluster and provide you with capabilities to survive any single node or disk failure with no downtime and no data loss. Each of those servers are loaded up with some amount of SSD and spinning disk, with the SSDs being used as a caching layer, so a read cache, a write cache, and metadata to accelerate your I/O performance. And the spinning disk is leveraged for cold data and to provide you with high capacity at low cost. Within each server, you'll have your hypervisor running. On top of that hypervisor is MXSP, the Maxta storage platform. So for example, in a VMware environment, this is a lightweight VM, which is communicating with the local disk within that server, and it's also communicating across the storage network to other nodes in the cluster. And then those services, that Maxta storage platform on each node, is providing you with the Maxta global namespace, which is, again, in a VMware environment, for example, is a single data store presented to all of the nodes in the cluster with the aggregated capacity of all the disks across the cluster. So now when you deploy VMs, you select your Maxta storage. When you write data, you select Maxta storage, and you get all the enterprise class features. All of your writes are being directed to SSD first, and they're being wide-striped, and we'll discuss a few of the other data layout and kind of other policies that we have, again, during the demo today. So now kind of going back to, those 3 key components, I want to focus a little bit here on software agility, and then the rest of the presentation will be focused on the application-defined policies. So with software agility, right, if you look at the traditional storage model, when you acquired your storage, you were buying the hardware and software together, and you were getting a non-transferable software license. So you'd buy your array, you would get the software, which maybe, let's say the software was costing you $60K and the hardware was costing you $40K for a total of $100K. Of course, all those costs were hidden. You just bought that $100K solution. But now when you hit the refresh cycle at, say 4 to 5 years, you had to throw away both the hardware and the software and reinvest that full $100K into your new solution. So hyper-converged appliances came in, and they actually do the exact same thing. They're packaging together the software with the hardware and giving you that non-transferable software license. And now when you need to refresh, that may even be on a quicker cycle now because you're refreshing your server rather than your storage. And the server and storage are packed together, and you want to keep up with, again, that V3 to V4 processor or whatever other innovations there are within the server technology. To refresh your server, and again, you have to repurchase both the hyper-converged software and the hyper-converged hardware. Now, Max has come in, and we're trying to change this model, right? We're going to give you that transferable software license where on renewal, you only need to purchase your hardware. So you can stick to that quicker renewal rate on the server side without having to worry about any overhead associated on the storage side, because that software license transfers over to your new hardware when you purchase it. So Maxta gives you this ability to purchase the hardware you need when you need it without having to repurchase storage software. All right, and now we'll talk through a few slides here on application-defined storage before hopping into the demo. So what do we really mean by application-defined storage, right? Let's look at kind of, again, the traditional storage, the hyper-converged storage, and application-defined storage, and what each of those 3 approaches bring to the table. So in traditional storage, you did have this ability to define your storage for each application. Of course, that came with some of the negatives that we talked about with the complexity and the cost. So what we're saying here, right, is in traditional storage, you could have 3 LUNs, LUN A, LUN B, LUN C, and LUN A could maybe be supporting your Exchange environment, the second LUN could be for VDI, and the third could be for database, and each of those LUNs would have unique RAID characteristics and maybe even the ability to configure the block size to match up with the application. Now, hyper-converged storage has come in and has addressed the negatives of the complexity and the cost by making it simple and cost-effective, but hyper-convergence, for the most part, is providing you with a uniform pool of storage wherein all of your applications are going to run on this single storage pool with the same attributes. So you have Exchange running side-by-side with VDI, running side-by-side with your SQL database, and maybe that storage is only optimized for VDI. So your VDI could be performing great, but your SQL and your Exchange will be taking a performance hit. And so Maxta and Maxta's approach to application-defined storage are trying to bring you the best of both worlds. So keep the simplicity, keep the cost-effectiveness, and bring back that ability to define your storage on a per-application basis. So you can see here we have Exchange, VDI, and database all running on the same Maxta storage pool, but each of them configured with their specific application-defined policies. And again, I'll discuss this more when we go through the demo and show you how simple it is to really configure those policies on a per VM basis. So now, what does this application-defined really bring us? And I'll discuss here very quickly 2 use cases that Maxta has gone through, and just kind of the benefits that we've seen just by changing. In these 2 examples, all we're going to discuss is changing the storage block size to align it with the application page size. So the first one is Microsoft Exchange, right? What we did in each of these tests, the next one that we'll go through is Oracle Database. With Microsoft Exchange and Oracle Database, both of them we set up the same way. We ran a random 4K I/O workload in the background, and then we deployed Exchange or Oracle Database with the 4K page size first, and then after that we deployed those Exchange or Oracle with their proper page size. So in this case, we had that 4K I/O workload running. We ran jet stress to simulate a workload on the Exchange environment. The first time we ran jet stress in a 4K environment, the next time we ran it with 32K, and we saw a 20% improvement just by changing the page size. And if you estimate around 0.4 IOPS per user, we saw in our environment that this would allow you, with that same hardware configuration, to support 400 additional users just by changing the page size. Now, similarly with Oracle, we ran that same 4K workload, had Oracle Database with HammerDB as the workload for the database running on a 4K environment entirely, and then we switched it to have Oracle running in 8K with the same 4K random I/O workload in the background. And again, we saw that 20% performance improvement in IOPS and a 19% performance improvement in transactions per second. You can really see here kind of how this simple tuning will bring you a significant performance gain. And with that, we'll hop right into the demo where I'll kind of show you how you can configure your environment and configure your VMs with those application-defined policies.
This is MX Insight Dashboard, which is going to provide you with real-time and historical statistics at a cluster level. For the purpose of this demo, I'm going to jump straight into MX Insight's VM Creation Wizard, and from there I'll show you how we can create and modify VMs to have application-defined policies. So when it comes to creating a VM, it's important to note that there are 2 ways to create VMs in a Maxta environment. The first method is the way you're probably most familiar with, which would be through your hypervisor, either using the vSphere client, for example, or maybe a hypervisor API or CLI. When you create a VM this way, you'll go ahead and select, say, the Maxta data store to use as Maxta storage for that particular VM. Now, when you deploy the VM to that Maxta storage, you're going to get all of Maxta's default policies, things like 2 replica copies and horizontal striping, and other policies that we'll cover later in this demo. But keep in mind, these policies that are set by default can be adjusted after the fact by going into MX Insight's Manage VM screen. The other way to create a VM is through MX Insight's VM Creation Wizard. When you create a VM using this wizard, you're able to set all of those policies at the time of creation of the VM. So if you look back, both of these methods can produce the same end result with your application-defined policies. Just that MX Insight's VM Creation Wizard will give you a single workflow to set these policies at the time of VM creation. So as an example, when we created the base 4K VMs that were responsible for running the random workload in the background during our test runs, we just went ahead and used the hypervisor's UI. And that's because for those VMs, there were no application-defined policies, and we kept all the settings as default. Even with the first run of the Exchange VM when it was set to default policies, we created that through the vSphere client also. Now for the second test run with application-defined policies enabled for that Exchange VM, we entered into MX Insight's VM Creation Wizard and the Manage VM screen to set and modify the necessary VM policies. Alright, let's get started. You'll see here on the first few pages of the VM creation wizard that there are going to be several characteristics which are common, whether you create that VM through MX Insight or through the vSphere client or other hypervisor utility. For example, we're going to have to provide things like a VM name, an OS type, an OS version, and CPU and memory resources. On the next page here, we have the ability to select a host for the VM's compute resources to reside on. Now keep in mind, this is independent of the storage layout, which we'll discuss with the application-defined policies on later screens in the VM creation wizard. Here we can attach an ISO to the VM. So for example, if you want to install the Windows 2012 OS, you could go ahead and attach the appropriate ISO and boot directly into that Windows installer. And then finally, we have VMNIC configuration. Okay, so now the interesting stuff. Maxta's application-defined policies. This is the disk policy page, and it's going to give you a few policies that can be set at a VM level. On the next page, we have vdisk creation, which is going to provide some policies that can be set on a per virtual disk or VMDK basis. So let's start at the top of the page here and work our way down. The first policy is going to be number of replica copies. By default, Maxta creates 2 copies of all data. This allows for the ability to have no downtime and no data loss when there's a disk or node failure in the cluster. If you want to have even higher levels of failure tolerance for a particular VM, you can modify that VM's policy to have 3 replica copies, or even more depending on the number of nodes in the cluster, and therefore you'll be able to survive multiple failures for that particular VM. In our test that we discussed earlier today, we configured all VMs to maintain the standard 2 copies of data. The next policy is rebuild priority. Rebuild priority is a number from 1 to 10 which determines the priority given to rebuilding the data associated with the VM. When a disk or node fails in a Maxta cluster, Maxta automatically performs resync operations in order to restore those VMs to a fully highly available state with 2 or more copies of data for that VM. During this process, all the VMs and their associated data from that failed disk or failed node are put into a queue, and copies of the data are rebuilt onto healthy disks and nodes elsewhere in the cluster. The rebuild priority for a particular VM specifies that you want that VM to be at the top or bottom of the queue so that it's restored to a highly available state sooner than other VMs in the cluster. Metro clustering is a policy within Maxta that enables failure domains. When you're installing a Maxta cluster, you can enable this feature and identify which servers belong to a specific site or rack. Then, when you create VMs and write data to Maxta storage, Maxta will ensure that if a VM is deployed to, say, Site 1 or Rack 1, that VM will have a full copy of its data available on Site 2 or Rack 2. In this way, if all the nodes in Site 1 go down, there will be a full copy of the VM available on another site in the cluster, and there would be no impact to cluster uptime. By default, Maxta stripes data across multiple disks and nodes in the cluster. This creates an even distribution of data and workload across all nodes in the Maxta cluster. It also provides each VM with the aggregated IOPS of multiple disks and nodes, rather than being constrained to the resources of a single node. However, the downside of horizontal, or sometimes known as wide, striping is that reads are going to travel across the network. In order to counter this, another approach to data layout is to have VM's data reside entirely within the node on which that VM's compute resources reside. This is known as vertical striping or data locality. With this model, all reads are going to be served from the node's local disks, which eliminates any potential network latency issues that you would see with horizontal striping. However, overutilization and some of the other factors that we discussed earlier do become an issue with vertical striping. So now the question becomes which implementation is better? And the answer is that it's going to vary depending on the workload of the particular VM or application. So the great thing about Maxta Storage Platform is that its flexibility with the application-defined policies is going to allow you to utilize either data layout policy depending on your application's specific needs. This contrasts to other solutions which force you to stick with either horizontal or vertical striping for all of your VMs. With Maxta, you simply check or uncheck the striping checkbox, and you will get either the horizontal striping or the vertical striping policy for that VM's data. Now for the test cases we discussed earlier with Exchange and Oracle, we wanted to isolate the performance differences specifically to just the page size, so we left all of our VMs with the default horizontal striping policy. The final policy we have here on a per VM basis is what we call node affinity. With node affinity enabled, you can actually isolate data of a VM to a specific set of nodes within your Maxta cluster. So we generally find that this could be useful in a larger cluster where, say, there are 3 nodes with NVMe SSD and 15K RPM SAS drives, while the other maybe 7 nodes have SATA SSDs and 7.2K RPM drives. So for the VMs that require the high performance of NVMe, you can actually come in here in the node affinity policies and set it up to ensure that that VM's data, which requires the high performance, will only reside on the nodes which have the higher performing storage. Moving along now to vdisk policies, Maxta allows you to set policies for disk size, SCSI controller, page size, read cache, and compression. And you can even apply those policies to multiple vdisks at the same time. So typically, we'll add a small capacity boot disk for the OS and then create some data disks. You can see through this drop-down menu, you can actually select the page size for each particular vdisk. So now going back to the test cases that we discussed earlier, you can see that for Exchange, we set this parameter to 32K, while for Oracle DB, based on the documented best practices and based on the best performance results that we saw, we set the data disk here for 8K page size. Now when it comes to SCSI controller type, we have seen the best performance in our own testing when using VMware Paravirtual Adapter. Finally, at the bottom here, read cache and compression can also be enabled or disabled on a per vdisk basis. Now just quickly for this demo, I'll go ahead and create one 40 gig boot disk and then one more 100 gig data disk. After clicking submit and beginning the VM creation process, we're automatically redirected to the Manage VM screen. From here, we have visibility of all the VMs that have been deployed to Maxta storage. And we have the ability to perform various operations on any of these VMs. So we can power them on and off, we can take snapshots and clones, we can view the VM console, and a few other things. And now that our VM has finished deploying, you can see here that we have the ability to modify all of the VM level policies that we just discussed. And we also have that ability to change the vdisk level policies. And it's important to remember that these functions will apply for any VM deployed to Maxta storage, whether that VM was deployed through MX Insight or through the hypervisor UI itself.
All right, so I hope that gave you guys a good understanding of kind of how simple it is and how easy it is to really configure these application-defined policies on a per VM basis within a Maxta environment. And so just to wrap things up here, the 4 key tenets that we talked about when it comes to Maxta are that ability to maximize your choice, maximize your flexibility, simplicity, and maximize your cost savings, all while providing you with high levels of data resiliency, availability, and protection. And so with that, I will go ahead and pass it back off to Scott, and thank you guys for listening and enjoy the rest of the presentations.
Arjun, thank you very much, as always. It's always good to hear what's happening with Maxta. We have just 1 or 2 questions that we're going to ask because we want to make sure we stick to a schedule today given the length of the event. The first one is, can you talk a little bit about Maxta's Hyper-V support?
Yeah, sure. So as of today, Maxta has support for VMware vSphere and KVM, and we are looking at Hyper-V down the road.
Okay.
The key here is that the platform was developed to be hypervisor agnostic, so there are just certain plugins that we'll need to develop as each hypervisor becomes more of a need to support within the data center.
The other question is support for Oracle. The question the person asked was, does Maxta support running Oracle on the platform?
Yeah, so again, because we run as essentially as a virtual machine within a VMware environment, we're an application on top of the hypervisor. Any other VM or service that plugs into that hypervisor should have no issues running alongside Maxta. And so Oracle database can be deployed on top of Maxta storage. And we have tested, as you saw, we have tested that in our own environment.
Sounds good.